So before we dive into today's session, we would like to take a minute to introduce Hatch and share what we are building. Today, students and early professionals often learn on one platform, network on another, showcase their work somewhere else, and discover opportunities on yet another. We believe growth shouldn't be this fragmented. That's why we are building Hatch, a community where students, early professionals, freelancers, and aspiring founders can learn, connect, build, and grow together. At Hatch, we believe the best learning happens through real world projects, meaningful conversations, communities, and interactions with industry experts. We also believe a resume tells only part of someone's story. The work you have built and the problems you have solved deserve a platform of their own. That's why we're building a proof of work driven ecosystem where people can showcase their work, receive feedback, and build credibility through what they have created. Sessions like today are a part of that mission, bringing practical industry insights directly to students. We are delighted to have all of you with us today, and we hope you have a great learning experience. Tanish, bye.
So hello everyone, I am Tanishka Yadav from IIT Bombay. We are delighted to have Mr. Tarun Jain with us today. Tarun is an AI researcher at Qdrant Labs, a Google developer expert in AI, a Qdrant Distinguished Ambassador. Over the years, he has worked across AI research, large language models, production AI systems, previously serving as a lead data scientist at AI Planet and as a founding engineer. He is also key contributor to open source AI projects such as Beyond LLM and Open AGI that has been selected for Google Summer of Code for 2 consecutive years and actively shares practical AI knowledge through his YouTube channel AI with Tarun. We are truly excited to have him with us today. Tarun, thank you once again for taking the time to join us. We are looking forward to the session. Over to you.
Thank you, Prakhar and Tanishka for the introduction. And I hope we're gonna have a very interactive section because it's a build with the. I mean, whenever you build with AI, it should be in public, right? So whatever you learn, you have to share your knowledge. And if not, there are so many companies and startup who are adapting AI. They are building multiple apps. If you're on Twitter, you might have seen multiple people are building apps right, left, and center, right? So what we'll do is let's try to understand few of the important concepts specifically to search, where we'll be focusing on agentic RAG, what is RAG, then what are the different ways you can perform search techniques that can be used to build recommendation system as well. Right now, search is a very important concept because when you're working with AI, most of the times you will have your own data, right? So if you want to fetch right information to your large language model, that is a very critical step, right? So let's get started. Let me remove this screen. And again, to give a quick introduction, we will be learning about vector search and what are the different applications and how people are using it. When I say people, basically how Uber is using vector search in their own application. So that is what we will cover, and all the basic concepts, whatever you have, we will take an examples so that you will understand it better before we can jump to the code demo. Right. So here is a quick introduction about myself. As Tanishka has already mentioned, I work as a AI research, specifically founding engineer at Qdrant Labs, where we work with self-improvement of agentic workflows. And apart from that, I'm part of Google Developer Experts program for almost 3.5 years now. And previously, I've also come to IIT Bombay, where we collaborated with Consult IITB, which is a club that you have, along with Analytics IIB. The program was something related to Confluence 2026. So I was part of that program as well. And apart from that, I'm also part of Qdrant Distinguished Ambassador program. And I love contributing to open source. In the past, I've been part of Google Summer of Code for 2 consecutive years. In 2024, I was part of Red Lab. And in 2023, I was part of CM Microscope. All right. So let's try to understand what is the problem that most of us are currently facing. When we talk about AI apps, mostly what happens, you give the input, you write a prompt, you use an LLMs, you get the response. But most of the time, just prompt engineering is not very important. You need to also have context engineering. So what do I mean by context engineering? So let's take this as an example, right? I hope everyone knows what is a string, right? So I'll open my drawing board. I'll quickly write prompt engineering, and then you have context engineering. So basically, prompt engineering is just a string template. And this string template can contain certain instructions, or it can be a simple query. But when it comes to context engineering, it is not just a string template, rather it is a systematic workflow. So what do I mean by systematic workflow? Let's suppose you have your own data. You have your own data and you're supposed to give this data to the LLM, right? So it is not easy to directly fetch all this data to the LLM. There has to be a specific systematic approach on how to pass your data to the large language model. This is where we have multiple concepts like RAG is there. Now, what happens in RAG? You're saving your data inside a vector DB, and then based on the user query, you only pass the relevant context from your data. We'll talk about this in detail, but I'm just giving you a brief idea. So what RAG does is you save your data. This data can be anything. It can be your PDF, it can be YouTube video, it can be CSV file, it can be document, it can be Google Drive. So whatever data you have, you save that in your vector database, and then I will ask a question. So when you're building a chatbot, you ask a question to the chatbot. It looks into your data, get the relevant context, give it to the LLM, and then LLM will generate the response. So RAG is part of one. Then you have memory. Now this is also very important because let's suppose you travel a lot. When you travel, most of the time what happens, you have a specific preference. Like a restaurant, you prefer Jain food, right? So all the preferences, whenever you are building your itinerary, your LLM needs to know that. So memory, what it does, it saves all your preferences, and based on your requirement, it will fetch that result. So memory is also very important. And then you have other techniques as well, like structured responses. And then it can also be simple session service. So session in the sense, you might have used ChatGPT, right? You give a question, then you ask multiple questions. So all the previous question has to be saved in the session. So that's where having the systematic approach, this is where your context engineering comes into the place. So coming back to the slides, as I said, when it comes to context engineering, it is a systematic workflow. It is an engineering process on how you can get your data and give it to the LLM. Now that you know, the context is very important. Now let's try to understand how do we search the applications, right? So whenever we talk about search, one of the most important and the basic concept is a vector, right? So what does this vector mean? So vector is basically, it converts your data into vector representation, which is represented in a dimensional space. Now here is a very good example. Let me open projector TensorFlow. You can also try this out. I'll send it in the chat. So now if I open this projector, let's suppose I take a random keyword. So now if you see, if I click on, let me take a simple word. Okay, so now if you look at this word, I've taken terminal as an example. So based on the terminal, what other keywords are very close to the terminal? So if you see, you have different words here. Now terminals is the closest word. Then you have airport, then you have bus, you have passenger, you have airways, you have airlines. So now whenever you are doing search-based application, you have multiple keywords in place, right? So if you want to get the relevant results, you need to know how the words are represented based on the vectors. So you also calculate distance measurement. For example, if you see here, we are using cosine similarity. So based on cosine similarity, what happens? If two words are in the same direction, that means it is positive. If they are in negative direction, if they are in opposite direction, that means it is negative. They are not relevant. So what is the major goal? The goal is to understand the meaning and to understand what are relevant so that you can apply search, right? So for distance, basically we have cosine and we have Euclidean. This is a basic concept which we have learned in our curriculum as well. And now when we talk about vector search, again, it is represented in different kind of vector representation. First, you have dense vectors, which is basically for vector matching. And then you have sparse vectors, which is basically for keyword matching. I will explain this in simple words in the coming slides. So you have dense for vector, you have sparse for keyword, then you have multi-vectors. If you have images, if you have audio, that is where multi-vectors comes into the place, right? So here is a very basic example of vector search, which is Google Lens. So in Google Lens, if you just notice, you can just capture a particular image and it will give you what are the similar image that was retrieved. For example, you have this particular image, you just put Google Lens and you get the search results. So that is one example of vector search, right? Let's try to understand two different form of vectors. One is dense and one more is sparse. So now here, if you notice, you have multiple documents. I told you an example that you have PDFs, you have CSV file, you have multiple form of data. So you get your data, you use an embedding model. So once you use an embedding model, you're converting your raw data into vector representation, which is in fixed dimension. So what do I mean by fixed dimension? So let's suppose you have an embedding model, and this embedding model, it can be anything. You have Gina embeddings, you have OpenAI, you have Google. Then there are other players as well, like Coyer, and Hugging Face also has multiple embedding models. So now what is happening? You're having a text. For example, you have hello world. And now if you are using any embedding model, every embedding model has a fixed dimension, which is, let's suppose it can be 768. So as you can notice, these are all embedding models, and you have this particular model, and this particular model has a fixed dimension of 384. Similarly, I typically use Gina embeddings. So Gina embeddings, as you can notice, it is 768. So these are dimensions, right? So by dimension, in the sense, one dimension, which is vector representation. And once you give hello world, now what is happening is it will give you a complete vectors, and the length of this vector, let me just add 0.1, 0.5, 0.2, and 0.3. So the length of this particular vector will be 768. Now, what do I mean by fixed? Here, if you notice, it is just two words. Now, if you are giving two paragraphs, now two paragraphs is very lengthy. Let's suppose you have a paragraph about IIT Bombay. So these two paragraphs are related to IIT Bombay. And now, if you are giving the same two paragraph to the embedding model, the output might be different. The output, the values can be like 0.7, then you can have 0.9. The values will be different, but the length will always be 768. So when we talk about dense vectors, the output will always be fixed based on whatever dimensions that particular embedding model was trained. Now, what is the purpose, right? So if you notice the heading, I said dense vectors are basically used for vector-based search. So by this, we mean if you're searching for anything related to AI, you might get AI, you might get deep learning, you might get neural network, you might get classification, regression models. So if you notice, you're searching for AI, but you got different keywords. So when we say vector search, it is basically getting the results based on the semantics. It is searching what are the similar meanings, similar to what you saw in the TensorFlow projector. So if you see here, even though the keywords are different, you're getting this result. This is based on the meaning. This is where you have dense vectors. And where is this useful? For RAG. So basically what will happen in RAG, you give a user query. Let's suppose I have my data, which is a resume. My resume is saved inside a vector DB. So now I will ask a question. What is the work experience of Tarun Jain? You will use an embedding model. You will get a query vector. Now what you're trying to do is you're searching into your vector DB and you will get the relevant chunks. So if you see here, what is the work experience of Tarun Jain? You will get documents, which means it can be my work experience at Kaivid Labs, work experience at AI Planet, work experience at Google Summer of Code. So once you get all this context, you're giving it to the LLM. So all these things are chunks. And this is where, based on the meaning, you're getting the relevant documents. That's where we use dense vectors. Then you have sparse vectors. Sparse vectors is basically keyword-based search or lexical-based search. Now, this is very useful when you're building recommendation systems. For example, I told you, right, if you are searching for AI, what dense vectors will do is it uses vector search, and it will also give you documents like neural network. Then it will also give you deep learning and neural networks, deep learning, then machine learning. So all these three keywords are different words, but still it is same relevant to AI. Now, when we talk about sparse vectors, it is basically keyword search. it will only give you those documents where AI is mentioned. So if AI is not mentioned, it won't give you that result. That's where sparse vectors are very important for keyword based matching. So I hope you understood the difference, why we used keyword and as well as dense vectors. This is one example on how keyword search is used. So you have a word called fruit bat, and then you're using tokenizers. So in tokenizer, what is happening? You're splitting the word. And once you split the word, you're looking into the vocabulary and you're assigning a value. So once you assign the value, you're using keyword-based algorithms. It can be TF-IDF, it can be BM25, and there are also other models like Splade, which is mainly used for sparse search. So now if you look at this TF-IDF, it uses based on the distribution. What was the frequency of a word that was occurred? And then you give a score. So once you get the score, you rank the documents above. So these are the two examples. Now that you know what keyword search is and what vector search is, here is how it is represented. So let's suppose my query is neural network. In keyword search, you're getting neural network only. It misses out deep learning and AI. But when it comes to vector search, it will find neural network and it will also find deep learning, AI, and machine learning. So what hybrid search does is it will combine both keyword search and as well as vector search. So this is the last part of my talk before we can go to the demo. That is how whatever you have learned so far, which is dense and vector search, how do you typically use this in order to build apps? Now you know the basic of search. Now the focus is using this knowledge, how do we build apps? So let's cover two basic areas. One is agents and one more is RAG. So basically, what is an agent? Agent is basically it interacts with the real-time information, gets the real-time information and give it to the large language model, and it applies reasoning. So there are two things that is happening here. One is getting the real-time information. Second is applying reasoning. So when we talk about reasoning, it is pretty different than the base LLMs, right? So let's take an example. Assume there is a FIFA match going on. Let me open my drawing board. So the query is, how much goals did Brazil score against Scotland? So this is the question. Now this match happened today morning. So LLMs doesn't have this particular knowledge, right? Because LLMs are trained on the own data. And if there is any real-time question, you're not basically using LLMs, rather you use a tool. So now what is this tool? You use search, right? So even in ChatGPT, if you just open, you just click on this plus icon and you're using web search. So even if you're not clicking on web search, ChatGPT automatically picks the tool. So base LLM, when I talk about base LLM, doesn't have the knowledge on how much goal Brazil scored. So if you want to get the exact result, what are you trying to do? This query is passed to the web search. So this web search is a tool. And now what this will do is it will pass up parameters. So this parameter is like search, and it will be Brazil versus Scotland FIFA. So now if you notice here carefully, when I say query, this query is nothing but how much goals did Brazil score against Scotland. Then it is using search. Now when it uses search, it is calling that function and it will use these particular keywords. So this keywords is decided by LLM. So when you are building an agent, inside agent, you will run two LLM calls. The first LLM call will be, it will decide what tool to pick. So based on the tool, what it will try to do, it will take an action. So here, if you notice, you have multiple tools. Based on the user query, it is taking an action, and this is in dotted lines. So if you notice, this tools is in dotted lines, which is taking an action. So now agent will directly interact with that action, which is this particular part. So it will search Brazil versus Scotland FIFA. Now this keyword, whatever you see here, this keyword is not there in my particular query. I mean, I did add Brazil and Scotland, but I never used Brazil versus Scotland FIFA, right? So this is just an example. Now this entire thing is printed by LLM. Now what will happen? You have a function. This function will execute, the search function will execute, and it will give you the context. Once you get this context again is given to the LLM. And here is where the reasoning is applied. And once you have this reasoning, you have your final answer. So now if you notice this entire workflow, this is called function calling, and this entire workflow is called agentic workflow. So now if I come back, now you might be confused, right? Like, okay, LLMs can also do this, but what it makes different than agent? So here is a classic example. Just go to LLM, use no tools, and just ask good morning. And the return answer will be good morning. How can I assist you today? But the catch is the time is 7:30. So if you notice at 7:30 p.m., if you are just asking good morning, no matter what the time is, LLM will always wish you with good morning. But now if you look at an agent, you ask good morning, and if you connect a calendar tool, this is how the response looks like. Good evening, it seems it's still nighttime, but if you are greeting me with good morning, maybe you're preparing for a fresh start or a specific context. So now if you see, even though I asked good morning, it is giving me good evening. Now what are the two things that is happening? First, it is picking real-time information. So what tool do you think is relevant? Calendar is more relevant, right? So it pick calendar, it will get the action. So based on this action, it will tell you, hey, the time is 7:30 p.m. Now, once you get that 7:30 p.m., you are applying reasoning, which has a little bit of feedback. And once you do that particular reasoning, you get the final response, right? So this is the difference between LLM and an agent. So now that we know what is an agent, this is the final topic, which is RAG. So RAG basically has two components. One is retriever and one more is generator. So retriever is basically what you see under the red block. So what is happening here is retriever is where you save your data inside VectorDB, which is just once. So it can be anything. It can be your YouTube video. It can be PDF. It can be CSV. Get that video, convert into chunks. Now, why do we need to convert into chunks? As I said, every LLM has a context window limit. You can't pass entire data to your you can't pass your entire data to the LLMs. Before that, you need to apply engineering, right? So this is where what you typically do, you get your data, convert into chunking so that you can give relevant information to the LLM rather than the entire data. So once chunking is done, again, as I said, you can't directly give raw data. You have to convert your data into embeddings where you get vectors. So you have dense vectors, save that in the vector DB. Once it is saved, that's where your retriever is completed. So you have retriever, you have generator. Retriever basically get all your data, save that inside the vector DB, which is offline. So this entire red thing is happening offline. Once your data is saved, then you can have your chatbot. So now in this chatbot, what will happen? User will come, he will ask his question. That question is converted into vectors using an embedding model. Now, if you notice here, you're getting context. So notice this example. You have 2 hours long podcast video, which is converted into 25 chunks. So now this question, whenever you're asking, you're only getting 3 relevant chunks, which are relevant to your user query. This document is given to the LLM, and there are 2 inputs. You're giving the query, you're giving it to the context, and then you generate the final response. So this is what RAG is. So in simple terms, if you want to build a chatbot like ChatGPT, but for your own data, that is RAG. And it is called knowledge transfer. Give the relevant information to the large language model to generate the final result. So I hope you understood this concept on what agent is and what RAG is. Now, what is agentic RAG, which is very important, right? So as I said here, there are multiple tools, right? You have calendar, you have calculator, you have code interpreter, you have search. So here you can also have something called as knowledge base. So let's try to understand this. Assume you have your data, which is IIT Bombay class notes. So you take all the IIT Bombay class notes and you're saving that in a vector DB. So you have around 5 PDFs. This 5 PDFs is saved inside your vector DB. Now what is happening? Once it is saved, once this is saved, your document is indexed. That means it is stored in vector DB. Now once it is stored in vector DB, you are building an app. So in this app, what is happening? You have a user. So this user first, what is trying to do is, your converting that into embedding model. And once it converts into embedding model, it will look into vector DB. And then it will give you the context. So once it gives you the context, you have an LLM. So LLM will take the user query, it will take the context, and then it will generate the final results. This is RAG. But how do we convert this into agentic RAG? So assume this embedding context, whatever you have, these two things, you can convert that into a tool. So what is the tool now? This tool is nothing but knowledge based tool. So I'll remove this. So this user will directly interact with an agent. This agent will have a knowledge based tool and it will have an LLM as well. So you interact your user directly to an agent, and this agent has access to your knowledge base and as well as LLM. Now, what is this knowledge base? It is just a simple tool, def tool. Then here you have query. Inside this query, you can have the logic. So what is the logic? The logic is convert into embedding, look into vector DB, and get the context. So all the logic, whatever you define, it will be inside the tool, similar to other tools. For example, calendar, you define a function. Inside that function, you have logic. Same, when you're building agentic RAG, whatever RAG solution is there, that will go inside a Python function. That function will be given to the agent. So you will use it as a tool. So this is very important, because when you're working with enterprises and startups, you will have to build your own custom tools, for example, on how Uber is building it. And as I said, it's again very simple. They have two parts. One is document processing. As you can see, you have enhanced document processing. Let me open this in article. So here, if you see, you have two key components. First one is offline document processing. Second is real-time answer generation. So what does offline document processing mean? You get your data, you save that in a vector DB. So here, if you see, you have multiple G documents, which is Google documents. You're extracting the information from Google Docs API. You're converting that into chunks by adding custom metadata as well. I'll talk about custom metadata when I will show you the code. And once that is done, you're creating table aware based chunking, which is the chunking process which they have approached. Then you use an embedding model. It's the same thing. So if you see here, get your data, chunking, then creating an embedding and saving it in a vector DB. So when you save it in a vector DB, you need to have two things. One is for vector and as well as keyword search. So once you do that, your document processing is completed. So this entire thing is your document processing. Then you have answer generation. Directly you're interacting with Slack interface. User query goes in. You are improvising the user query. That means I, as a user, might not add a better prompt. So internally, what Uber is doing is they're optimizing the prompt so that the LLM and agent understands what user is trying to convey. So once you have this user query, you're looking into your vector DB. It's still at this step. So if you see, you have user query. After you have user query, you're looking into your vector DB and you get the context. So you look into your vector DB, get the context. Once you get the context, you're giving it to the LLM for final answer. So we were only focusing on answer generation and document processing. Evals again is a complete different topic, which we don't want to cover in this particular session because this is off topic, right? So this is how Uber has built it. What our main focus will be is using hybrid search, using reciprocal rank fusion. Now, what does this mean? Now, here, if you notice, we know we want to combine keyword search and vector search. So keyword search will give you 5 documents. Vector search will give you 5 documents. Now you have 10 documents. Out of this 10, you only have to give 3 to the user. So you have to combine these two, right? That's where this fusion techniques comes into the place, which is reciprocal rank ratio, where you're taking the reciprocal of it, which is inverse. And let's try to get into the demo. We will try to start off with the code demo. And in the code demo, before we can jump to build any application, we have to set up the Qdrant cloud. So this is the URL. So you can just quickly scan this. The first thing what you're supposed to do is you have to sign up. And as soon as you sign up, you should see this particular dashboard, which shows create a free cluster. So we'll wait for 1 minute until you see this particular dashboard. And as soon as you see the dashboard, enter any cluster name. So for example, I've opened a different browser. So here what you can do is under cluster name, just write recommendation. If not, you can also give IIT Bombay and click on create a free cluster. That's it. You understood what we did? In this dashboard, just enter any app name that you want to build. And once you enter any name, click on create free cluster. Nothing else you're supposed to do. Just give a name and click on create free cluster. And as soon as you do that, you should see this particular window. In this particular window, you will see your API key. What you have to do now is copy this API key. So you have your copy button, click on copy. Then let me share you this collab notebook. Copy and keep it safe somewhere. Make sure you don't lose that particular API key. This is the collab notebook. What you can do is create a copy of it, create a copy, and here remove user data.get Qdrant API key and paste your key. So notice your starting two keywords will start with EY. Copy this API key, come to your collab, paste that particular API key. Paste your API key over here. I repeat, whatever API key was generated, copy it. And I've shared you the collab. In the collab, when I have Qdrant API key equals to user data.get, remove that user data.get and enter your API key. Simple string, just enter. Now, what does this user data.get mean? In collab, if you have used collab properly, here you have something called as secrets. So now if I click on secrets, you can add any API key over here and you don't have to show that particular code to the user, right? So if I do live sessions, I don't want to show my API keys to user directly. So what I can do, I can directly save it here. So create a new secret, give a name. For example, I'll just do Qdrant API key. And then you can paste that API key over here, key and value. So whatever key you define here, that is what you have to enter here. User data.get Qdrant URL. If not, user data.get Qdrant API key. In my case, I already have those. So if you see, you have Qdrant API key, you have Qdrant URL. But since you guys are not showing your keys to anyone else, that's the reason why I said remove user data.get and directly paste your API key over here. It will start with EY. So let me know if you have completed the API key. So once the API key is done, you also have cluster endpoint. Copy that particular cluster endpoint, come back, paste it, and then type colon, then just add 6333. So this 6333 is nothing but a port number, and this is your endpoint URL. So I hope you have completed the steps. You have Qdrant URL, enter the endpoint that you have created, just copy this endpoint, paste it, then just give 6333, which is the port number. Then you have Qdrant API key. So Qdrant API key starts with EY and you will have other keywords. So now what you can do is once you have pasted the API keys, we can start with the installation. Just do pip install Qdrant client. And there are three things we have to do now. This is the syntax. Let me write syntax. So the first thing is you have to define your client, define your Qdrant client. So there are three ways you can run it. There are three ways. The first one is the cloud, which we are doing now, like our approach. So when we say our approach, you are typically using cluster endpoint and API key. to access cloud. So this is the first approach. Second approach is, let's suppose you want to self-host. So in self-host, you have to locally host it. So when you locally host it, you are using Docker, right? So self-host is the second option where you have to locally host it and you're using Docker. Third approach is you're using in-memory. Now, what does in-memory mean? Let's suppose you have a project directory. Inside that project directory, you're creating a folder. So this is called in-memory. Similarly, in Collab, if you're using in-memory, if the internet goes off, your data is gone, right? Because in Collab, you can't save the data unless you don't have any internet, right? So that's where in-memory you can only use if you are using any single folder in the edge device. But usually not many people prefer in-memory. They usually go with self-host using local installation. If not, they use cloud, right? Which is managed. So this is managed. So you have self-host for local, then you have managed for cloud, and in-memory is like only for folder. So these are the three ways. So you define your Qdrant client. Once you define it, second step is configuration. So what does configuration do? What are the two different data vectors we have? There are two kinds of vectors. One is dense. Now dense is basically your vector configuration. And then you have sparse. So sparse, basically either you can use VM25 or you can use TF-IDF. Now when we talk about dense, what are we doing? We are using vectors. We are using embedding model, right? We are using embedding model. And this embedding model has two things. One is the fixed dimension. For example, if I'm using GenAI embeddings, I have to tell what is the embedding dimension of it. That configuration is very important. So what are you trying to do here? You define a dimension which is 768. And if you're using different embedding model, just find out what is the embedding size of it, get that particular number, add that in the configuration. Then you have distance. So what is the distance you are using? We are using cosine. So this is for dense. In sparse, you just have to load this particular model. Just load the model, either it is VM25 or TF-IDF. That's it. Is this clear? So first we define the client. Once we define the client, we have to create a configuration. So once we create this configuration, it will create a collection. So when I say create a collection, it creates a space where you can dump your data. As of now, we only have the configuration. Last and the final step is dumping our data, but we call this concept to be indexing. So what happens in indexing? If you notice our diagram, there are two things which is happening here. In VectorDB, you're passing your data, you're also defining your embedding model. So if you see your C and C, two things are happening. So here, when you do indexing, we have to create points. So this points is in a Qdrant vector database, but if you're using different vector database, this keyword will be different. But the process is same across all the VectorDB. Define the client, then create configuration, then index. Since we're using Qdrant, you have to define a points. So inside points, there are three things. One is ID, then you have vector, and then you have payload. Now the important question is, what is payload? We know that we are saving vector. ID, it's self-explained. It is unique number. Vector is nothing but your data is represented in numbers, which is in n dimension. Now, what is this payload? Right? This is very important. All right. So let me quickly tell you what payload is. Let's suppose you're building a chatbot and you have around 100 documents. And now what is happening is when you ask a user query, you're getting the response from the AI. So this AI, what it is trying to do, it has a RAG chatbot, which has all the 100 documents. It will search from those 100 documents and it is giving you the response. Now my requirement is my AI should also tell from which source it generated that response, which is nothing but citation, like which PDF and what page number, right? So now you have 100 documents. Out of those 100 documents, you generated the response, but I want to know from which PDF you took that response and what is the page number of it. So these two things is called metadata, right? So metadata is typically added in payload, the additional information that you have to use for filtering, right? So these three things you have to define: ID, vector, and a payload. Once you have these three things, just use upload or upsert. That's it. This is the only thing you have to know when you are using vector database. Define the client, create the configuration for dense and sparse. If you don't want to use sparse, if you just want to use dense, just use dense. But if you just want to use keyword search for recommendation system, just use sparse. But if you want to use hybrid, use both. And once you configure it, last step is indexing, where you have to define points, define an ID which is unique, vector, and payload. Payload is nothing but your metadata, which is basically used for filtering. Once you upload it to VectorDB, that's it. That's your document processing. So let's get back to the code. So here you can download the data. We have a movie data. So inside this movie data, you have user information. And after user information, you have movies information. Like there are multiple movies: Toy Story, Jumanji, Old Man, then Waiting to Excel. And for every title, you also have genre. So using this genre, we can use it for keyword matching. And you also have ratings. So rating is basically, it ranks from 1 to 5. And since we are using sparse representation, 1 to 5, it will be too much. So what we are trying to do, we have to normalize. So for normalize, we are just taking mean of it. And once we take the mean of it, you're dividing that with standard deviation. This is, if you have learned neural network, you might have come across this normalization. It is called zero mean or unit variance normalization. And once you do normalization, this is how your data looks like, which is rating embeddings. It is between 0 to 1 or 1.5. So if you see, it will also be negative values. So now your data is normalized. And once you normalize your data, you just have to create the collection of it, which is nothing but indices and values. So this values and indices is nothing but will be fetched to your sparse. In sparse, we'll be using TF-IDF. So once you create your data, the next thing is we start with first step. So if you notice here, the first step is define your Qdrant client, and we have defined it. Qdrant client, give your URL, give your API key. We are done with the first step. Second step is you have to create a collection. In my case, I've already created it. So I will not run this particular cell because you need to run this once. This part only needs to be run once. Now, where do we confirm this? Come back to your cloud.quadrant.io. So here I have recommendation. So once you come back to your dashboard, you will see something called as cluster UI. So I'll just click on this cluster UI. And if you notice here, you have movie lens. So movie lens, and if you notice, we are using sparse. Now, why is sparse used? For keyword matching. So movie lens is already saved. So that's the reason why I will not run this again. So define your vector. I don't want to use any dense. That's the reason why vectors config is nothing. But for sparse, I'm defining ratings. So this is part 1. And next is the points. So as you can notice, you have point struct. And there are 3 things in points. One is ID, which is unique. Then you have vector, and then you have payload. So in this payload, we are just adding the user information, which is the metadata. Then in vectors, what are you trying to vectorize? We are vectorizing the ratings. And now you can just run this. In my case, this also needs to be run once. Once your data is saved already in VectorDB, you don't have to run upload every time, right? So creating the collection and uploading should be done only once. That's it. Once you do this, you just have to pass the real-time user question. For example, let's suppose these are my ratings, and matrix is basically this particular vocabulary. If you notice the diagram of sparse, so in sparse, if you notice fruit and bat, everything has a vocabulary, right? So fruit has 193, then bat has 9184. So for sparse embeddings, every word has a vocabulary. Here also, 2571 is for Matrix movie, then 329 is for Star Trek, then 260 is for Star Wars. So you are giving a specific rating for every single value. Now, if you don't like the thing, it will not recommend you those movies which fall under this particular vector space, right? So for Toy Story, I'm giving 1. That means this particular movie I like, right? So based on my ratings, I want to get the relevant recommendation. So give all the ratings of the movies of your choice, then create the inverse rating so that you can apply inverted index, and then have a function where you have to convert. So this step, if you notice, let me come back. Here you have your own information, which is user query. After user query, again you're using embedding model. So we are trying to convert our data into vectors, which is happening on the inference level. So whatever function you see here, this is happening on inference. This is happening on inference level. So in this inference, what are you trying to do? Whatever user input is there, convert that into embeddings, which has values and indices. Values and indices is only for sparse vectors. So once you do that, you are converted your vector embeddings. That's it. You just have to use search. So for search, just use client.queryPoints. So query point is a function to use search. Give the collection name. So collection name is movie lens. So let me just write, this is collection. Let me hover on this. And if you notice, this is the parameter, which is collection name. Collection name equals to movie lens. Then you have query. So whatever user input is there, you have to convert that into vectors. Then using ratings. So what does this using equals to ratings? Here, if you notice, my sparse vectors, I give ratings. So if you give anything else, for example, let's suppose I give Tarun. So for sparse embeddings, whenever I give any name, this name has to be repeated here. So if I gave there Tarun over there, here also it should be Tarun. Earlier, what it was ratings. So I'll use the same keyword and I will paste it here. So it is trying to see which particular name field am I supposed to use. So that name field is ratings. And then with vector equals to true, so that you can get the new movies. And this is the limit. I want to get 10 limits which are relevant. Just run this cell. And then once you run this particular cell, you have vectors. You want to convert that into names. So this is the conversion logic. You're converting the numbers into names. And once you do that, these are the relevant results, like Star Wars Episode 5, then Monty Python, then Rocky Horror. And you also have the scores for that, then Sixth Sense. So whichever is the relevant results, you're getting the results. Once that is done, let's jump to the code of case study. So now what we'll try to do here is, we'll start off with first thing, which is how to convert our data into chunking. And when you do chunking, they have also mentioned something related to custom metadata. Now, what is the reason they have done this custom metadata chunking? We will try to understand this. And once this is done, remaining thing is same. You just have to dump your data to VectorDB, then use it for real-time answer generation. You ask a user query, look into VectorDB, get the context, generate the answer result. The only thing is, we are not using evals for this example, but I have a video on this, so I'll share that video at the end. All right. So now the first question is, we are using LangChain. So what LangChain does is, let's suppose you have loading your data, then chunking the data, then embedding, and then using VectorDB, then using LLMs. So if you want to stitch all the components within the same workflow, that's where LangChain comes into the place, right? So you have LangChain, then you have LangGraph. All these things belongs to the same organization. Now the next thing is, we are using PyPDFM, and there is a research paper on why I'm using PyPDFM. comparative PDF parsers. So let me copy this, paste it here. And as I said, the data that we are using is related to finance. So if I scroll below, and now if you notice here, there are different frameworks. You have PDF Miner, then you have PDF Plumber, then you have PyMU PDF, then you have PyPDF, then you have PyPDFM, then you have unstructured. So all these things are frameworks that is used to extract the information from your PDF document, right? So if you look at the accuracy score, it is more for PyPDFM. So precision is more for PyPDFM, blue score is more, then also local assignment for finance related documents, which is our niche, right? But if you're using different PDF, let's suppose you're using something related to patent. So if you use patent, if you see here, PyMU PDF has more score for everything. So for patent, which is research papers and everything, you can go with PyMU PDF. And if it is something related to manuals or law, based on that, you can pick which tool is relevant, right? So now what Uber did, in Uber case, the data is already is in Google Docs. So now in their case, they directly used Google Doc API. So now what will happen? You have Google Docs, they have PDF, and using Google Drive or using Google APIs, they're converting that into Word document. And once it is in Word document, for chunking, they're chunking it based on HTML and Markdown format. This is also something that they mentioned. So challenge one was extraction, and they used Google Docs API. In our case, we are using PyPDFM. Now comes the challenge two. Now what is the challenge two? Making better retrieval. So what does better retrieval mean? When you are asking any question to your vector DB, you need to extract relevant information. So how can you extract that pretty well? When you have more relevant tokens or keywords. So here what we are trying to do is we create custom metadata. So this custom metadata will include multiple keywords. It will include summaries, and it will include frequently asked questions. So again, now what is this metadata? I hope I don't have to explain this again, because when you have document, this document will have page content and it will have metadata. So metadata is basically source and page number. Now what we are trying to do is, apart from the source and page number, we want to add more keywords, we need to add summary, and we need to add FAQs. So what difference does it make? Assume in this 100 documents that I mentioned earlier, you have 10 documents related to HR, you have 10 related to technical, you have 10 related to legal, then you have 10 something related to manufacturing, and so and so. Now, when you ask a user query, which is related to legal, but instead of retrieving from legal, it retrieved the documents from HR. So what is happening here? You ask a query, you are thinking that query is inside legal document. But what retriever did is, it found something relevant in your HR documents and it gave you the context from HR. Now, whatever this context is there, that is wrong, right? Because you wanted something related to legal documents. But in HR documents, you have no information about that. So whatever LLM will generate, that is a wrong response. So in order to have relevant responses, what we are trying to do is, we are creating more metadata so that suitable information is going there. So every chunks that you create, so let's suppose you have 100 documents. This 100 documents will create around 400 chunks. So every chunks that you have, every chunk will have source like hr.pdf. Let's suppose hr1.pdf. Then it will have page number. Then it will have keywords. So keywords you can generate using LLMs. You will have some keywords. Then you are creating summary. So what is the summary? Let's suppose you have hr1.pdf. That entire document summary, you are adding it here, so that this particular chunk knows more additional information. This is what even Uber did. So if I scroll below, so if you see here, for custom metadata, they added summarize of long documents. Then they also incorporated document summaries, then a set of frequently asked questions and relevant keywords data into metadata. So this is very important so that when you're doing retrieval, you can pass relevant information and get the results. So this was the challenge to have better retrieval. So what did they experiment with? They experimented with custom metadata. So in custom metadata, they added keywords, then you have summaries, then you have frequently asked questions. You can use LLMs for this. You can use LLMs plus prompt, LLMs plus prompt. And here you can use any summary model from Hugging Face. All right, so this was the challenge 2. Challenge 3 is search. So for search, they use hybrid search. So I hope you guys know what hybrid search is now. Here, if you notice, you need to combine your vector search and as well as keyword search. For keyword search, they are using Beyond 25, which we are using in our demo as well. And once you do this, here at this point, when you have to combine it, we are using RRF, which will give you the final chunks. So these are the 3 challenges. 4th challenge is the evals, which I'll not talk in this particular session, right? So let's get to the code. I will not run the code. I'll just explain it. And there is also one new tool you might have seen, which is OPIC. So here OPIC, what it is trying to do is, it is a LLM observability. So you ask a question, you get the output, you are using tool calling. I want to save every prompt that you write in a dashboard so that if something goes wrong, I can go check it, trace, monitor, and then evaluate. So that observability tool is OPIC, which I'm using. And here in our diagram, if you notice, we need an LLM. This LLM is basically a Gemini LLM. So we need Google API key. So this is for LLM. Then Qdrant client is our vector DB. And fast embed is our embedding model. Fast embed is the embedding model. So embedding model comes into 2 places. Here is one, and then here is one. So these 2 places we are using fast embed. So now that we know what frameworks we are using, the next step is we need to configure the API keys. So for OPIC, we need to have OPIC API key, workspace, and project name. But if you don't want to trace this, for example, you can just remove OPIC, OPIC dependency, right? So you can just remove it because it is just to trace and monitor. And then you have Google API key. This is very important for LLM. Then you have Qdrant API key and Qdrant URL. This is something that we have already seen, right? So once you set up your initial information, then you can bring your own data, the data of your choice. If it is related to IIT Bombay, you can bring those data. If you're building chatbot for your company or gaming company or any manual, get those data and save it in a folder. So let me show what data I am using. So if you just open this particular GitHub repository, so here you have SEC filings. And as I said, SEC filings has 10K PDF, 10Q PDF, and 8K. This is just the names for it. Then you have shareholder letters. So there are total 5 documents. I want to save these 5 documents inside my vector DB. But if you want to use anything else, just save that inside data. And once you save it, I'm loading the file directory. Inside this file, I have data. And once you get the PDF, I want to use PDF parser. So load that particular instance. Now the syntax for LangChain. If you are using parsing tools, let's suppose you have YouTube, you have PDF. The first step is you need to import. The second step is you need to instantiate. Third step is you have to load. It is just 3 lines code. So first thing is import. Once you import, the next thing is instantiation. This is what you call as instantiation. Once you instantiate, just load. And as soon as you do this, you have your documents. So now if you see, every document has 2 things. One is metadata. And apart from metadata, you will also have something called as page content. Probably it will be somewhere down. But I have not defined it because I just wanted to show what a metadata is. Here you have source, you have total page, and you have page number. So define metadata, and then I'm adding custom metadata as well. So as I said, for summary, I'm using Hugging Face tool. So this is the summary model. And once you have summary model, you are also creating chunks so that you can summarize based on chunk level. And then I'm adding additional keywords. So wherever I see 8K, I'm converting that into 8K filing. If I see 10K, I'm converting that into 10K filing, then 10Q. If I see shareholder, I'll convert that into shareholder letters. So far, we just loaded our data, creating metadata. Once we create the metadata, we are updating our entire data. So now once you update this, you have new metadata which has been added. So here, if you notice, I commented these two cells. In your case, what you're supposed to do is uncomment this and try to add this example by yourself, so that after workshop you have something to do by yourself. So if you see here, generate tags and FAQs, I've not written the logic for this. So what you're supposed to do, just create a new function, use an LLM, and generate the tags. So that's why I said try this by yourself. And once you do this, it's the same thing. You will not get any errors here. You're only adding new metadata. Since metadata is a dictionary, creating a new dictionary is very simple. Just define that particular variable. Metadata is your dictionary. Create a new key. So the new key is chunk summary, chunk tags, and document type. But if you want to add any metadata of your choice, you can do that. But if you don't want to use custom metadata, you can ignore this entire step. Right? Now, once the metadata is done, the next part is step 1 is done, step 2 is done. Step 3 is define your vector embeddings, save that in a vector DB. Now, what is the logic to save into vector DB? These 3 steps again. First, define a client. Once you define a client, define a configuration, then use indexing. So I'm defining hybrid search. I'm using fast embed for text embeddings to use an embedding model. Then you have sparse embeddings where we'll be using BM25. And here I am defining quadrant client, and then you have points. So first step is this one, define your quadrant client. Then collection name is case study. It has to be unique. So now if you see dense model name, so the dense model name is GenAI embeddings. So if you just copy this, search for supported models fast embed, search for this model name. So if you see here, GenAI, Gena embeddings v2, the dimension size is 512. So you copy this 512, and when you are creating the configuration for dense configuration, dense, the distance measurement is cosine, the dimension is 512. Same syntax. So configuration, define your dense, define your dimension, which is 768, define your distance, which is cosine. Once you define your dense, then you have sparse. So for sparse, we are defining IDF, where we will be using beyond 25 as an algorithm. And this beyond 25 was also used here. If you see here, beyond 25 retriever. So once this is done, you are creating a collection. And after you create collection, what are we supposed to do? We are supposed to create points, which has ID, vector, and payload. Once you have these 3 things, directly use upload or upsert. So you have points. So in these points, if you notice, you have ID, which is unique. Then you're creating vector representation for both dense and sparse. Why? Because I need hybrid search. Then you have payload. In payload, what am I trying to do? I'm just adding my metadata. So if you see metadata, this is for filtering. Once you do this, you have your tool in place. So just ask a question, mention the success information of K-pops demon hunters. I need to get 3 relevant information. You're using prefetch for both sparse and dense. This is where you apply your hybrid search. Once you apply your hybrid search, you need to use fusion. So for this fusion, we are using RRF, which is basically your reciprocal rank fusion. And once you do this, you get your search results. So these are your search results, which will go as a context to the large language model. Till here, we have completed the first step, which is retriever, right? This is document processing. It is same. The only thing is different logic, because earlier we didn't use vector. We didn't use dense vectors. Here we are using dense vectors. That's the only difference. So here will take some more time. And then if you have any doubts, I'll wait for 1 minute and then I'll proceed with answer generation. So this is for the filtering logic. If anyone wants to apply filter, I've just added the logic for filtering. But filter is always optional, because if you notice here, filter condition, I've added it as optional. So you don't have to worry about filters as of now. So I'll wait for 1 minute, then I'll start with answer generation, which is the final part of our code. All right. So now that we have completed with the retrieval, so what happens in retrieval? Whatever data is there, it is saved inside a vector DB. And second thing is the augmentation. Augmentation is basically a prompt. You don't have to worry about writing prompts. So prompts, how do you define it? First thing is you have to define a system prompt. Second thing is you have to define a user prompt. So what does system prompt mean? So let's suppose you're building a medical chatbot. So if I come and if I ask who is Virat Kohli, it should not answer that particular user prompt. Why? Because you built it for medical purpose. If you want to give control for your chatbots, we typically define system prompts. So here you can give role play, like what personality it needs to adapt to, and then you can define instructions, and then certain motivation if it performs that instruction, right? And then you have user prompt. Whatever user will enter, just pass that as a prompt. So user prompt is basically the user query. System prompt is basically the role play, instruction, and motivation. There will be one more thing in user prompt, which is context. So whatever you get from retrieval, this will be appended in your context. So these are your input variables. So both query and context are your input variables, which will be added in your user prompt. So if you see here, you have system prompt. So you are an expert financial assistant. This is the role play. And how are you supposed to use the user queries? You just have the prompt. So just run this particular cells. And once you have it, you have system prompt, you have user prompt. The last step is the answer generation, where we are using LangGraph. So for LangGraph, there are again three things. First thing is state. Then you have node. Then you have edge. So node is basically functions or logic elements. So what are the logic elements in our RAG pipeline? First one is search. Based on the user query, you're using a search, getting the context. That is a function, which I explained earlier. And second is the generation. So what is generation? Whatever context you get from search, you're giving that context to the generator to generate the final result. So you have two functions, search and generate. That is added as a node. Then you have edge. So what is edge? It will just connect. So you start, then you create a edge. This arrow mark is your edge. You start with search, then search output goes to generate, and generate will go to end. So whatever you see this arrow mark, it is your edge. And whatever you see this search and generate, that is your node. Now state is basically all variables if you want to persist. If you want to persist. For example, there will be variables which you will use in search. The same variables also has to be used in generation. So you have to maintain a state for it. If you have learned class and oops in Python, you might have known that when you create attributes in oops, you are creating a persist state of it. So all the attributes that you add inside your class, that can be created in your object as well, right? So that state you're defining as a variables, it is just attributes which can be used across the nodes. So nodes is your function which defines the logic. Edge is basically how do you connect it. So now if I come back to the cell, you create a particular state. So query is my one variable, context is another variable, and answer is another variable. Filter condition, it is optional. If I want to define it, I'll define it. If I don't want filter, I will just ignore it, right? Then you have search. So this logic is same. If you notice, first you define prefetch, where you define your sparse and dense for hybrid search, and then you use client.query points to get the relevant context, where you're applying the fusion, which is RRF, the same thing which we saw earlier. And after that, you're getting the context which you have to return. This is the first node. So if you see here, this entire thing is a node and it is running inside a state. So this state is very important. Every node has to be represented within the state so that you can use this particular value. So if you see here, uh, where is the input variable? Okay, it's here. So if you see here for generate, you have state, then you have context. So this is what you call as persist directory, right? Your variables are persisted. So this state comes from your generate, and inside that you have context, which is returned from search. And if you scroll below, you will also find state of query. So you can't give question here. So if you want to give question here, you have to define it inside your state. So whatever variable you define it here, if it is query, same thing you can define it within your state. So just make sure you use the same variables for state persist. And now you have two nodes. The first one is search, the second one is generate. So in generate, what are we doing? We are getting the context using the LLMs, and using LLM you are giving both your system prompt and user prompt, which has context and user query, and generating the final result. So once you have this result, you just have to return the final response. So this is how the edge looks like. You have start, then you use search, then you use answer generation, and then you use end. The only thing what you're supposed to do is you have to learn LangGraph. And when you learn LangGraph, just try to understand how to define nodes. And once you understand nodes, how do we connect it? Whether you need sequential, whether you need parallel, whether you need routing, there are different APIs on how you can add your edge. In our case, we went with sequential. How? Just workflow.added, start, then search context. Search context is your node 1. Then search context goes to answer generation. Answer generation is our second node. Answer generation goes to end. That's it. Once you define this edge, you get this particular workflow, and then you can ask any question like mention the success information of K-pop's Demon Hunters. So it had around 80 million views, and it was biggest animated film ever, according to the Netflix 2025. So all those information can be retrieved from your graph. So this is it from the Agentic RAG. Probably if you start learning LangGraph, you will be able to relate these concepts very well. But the major takeaway from today's session is what is hybrid search and how to define vector databases, like defining the client. It can be managed, which is your cloud, then self-host for local, then in-memory. And for just vector search, you have to define dense. For just keyword search, you can define sparse. But if you need hybrid, you can use combination of both. Once you define configuration, the last step is indexing. So based on the vector databases, the logic will be different. Here it is points, but these three things will remain same. Payload, the concept is same across all the vector databases. It is used for filtering mainly on metadata. Then vector, whatever raw data you have, you convert that into number. So these three things will remain same, but the variables or the functions will be different. So yeah, this is it. But if you want to learn more, I have a YouTube video on how to generate the complete evaluation data set. This again, as I said, it's a complete new topic. If you notice, the hybrid search of Agentic RAG itself was 24 minutes, but how to create data set was around 32, because it is completely different topic and it requires more depth in it, right? So once you understand how to build RAG, how to build agents, then the concept of evals comes into the place. You can just check out the videos. You have it step by step, like basic, then intermediate, then advanced. This is the YouTube URL. If you are interested in learning more, you have few resources over here. And yes, if you are facing any issues, if you are running it into any errors, just take the screenshot, send it across LinkedIn or Twitter.
Thank you so much, Tarun sir. That was a truly insightful session. I think everyone here has now a better understanding of what actually happens behind modern AI applications, from how information is retrieved to why concepts like vector search and hybrid search have become so important in building reliable AI systems. We really appreciate you taking the time to share your experience, practical insights, live demonstrations, real world case studies with all of us. We'll now move to Q&A session. If you have any questions, feel free to either raise your hands or drop them in the chat. We'll take them one by one.
How to start contributing in open source?
Okay, so basically, what I prefer is pick any skills of your choice. then start reading case study articles. For example, when you start contributing to open source, the first thing is you need to get confidence, right? Because as soon as you open any open source project, you will feel overwhelming because there are so many code files. So what I will recommend is start building projects which make sense. So only those projects make sense when you know, okay, this particular project is used in any startups, they're used in any companies. For example, the case study articles, there are so many engineering blog articles from Uber, then you have Netflix, then you have Pinterest, then there is also Data Coach and Data IQ. There are multiple companies and there are multiple startups which release their case study blog articles. And if you are not able to search them, there is one platform on ZenML. All these case studies have been, let me share that URL. So here you will find more case studies, so that what you can do is, based on your tech stack, if you know Python, if you know any framework, list down those engineering blog articles where you can contribute. Now, once you know, okay, these are the use cases that I can build, next step is see if there is any existing GitHub repository or any existing Kaggle profile where you can just copy paste, right? So once you copy paste, you will understand how other people are writing code. Then you start building your own. So first step is getting the use cases from case study articles, then trying to copy paste the code to understand how actually it is written. Once you understand the syntax, once you understand the flow, third step is you start building by yourself. Now here what I typically do is, let me share my screen. So when I try to build anything, I try to create flow charts so that I can understand what am I supposed to do. So here, if you notice, I built something related to multimodal search, where I want to combine image and as well as text embeddings to get the result. So before you can go implement anything, try to create flow chart architecture diagrams so that you get clear cut idea. So once you do this, you have your project, and try to do the same thing for 4 to 5 case study articles. Then you get the confidence. Then start contributing to open source. Pick a repository, look at their examples folder, and let's suppose after 3 articles, if you feel some function is not doing right, so you can go check that particular search code, then you can just improvise that particular script. So the flow will be case study engineering blog articles based on your tech stack, and then try to copy paste few of the case study available on GitHub. So this is just to give you a clarity on how this is actually written. But if you're not able to find this, you always have Claude. Just give this entire engineering blog article along with architecture diagram to Claude. Tell, hey, this is a complete article. Can you just give me a smaller use case of it so that I can try to build it? So Claude can also give you that entire code. And once you have this, the next step is look for new articles and build it yourself. So when I say build it yourself, you need to write code by yourself. Here you have copy pasting. Here you are doing it by yourself. So when you do yourself, start with architecture diagram. So in architecture diagram, you will get clarity of what components to use, what is your input, what is your output. So you will know how to build it. This you have to repeat it for at least 4 or 5 until you get confidence. So have 4 projects, have 5 projects, get that confidence. Once you get that confidence, you will see a pattern. Okay, this particular function is not working fine. I will go to the GitHub repository and I will fix it.